Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh. Good day, everyone. This is Ziad Bouhlega, the Chemicals Petroleum Industrial Leader of IBM Consulting, Saudi Arabia chapter. And it is my pleasure to moderate the Smart Engineering session of the Project Execution Technology Hybrid Conference. The objective of this session is to present how smart engineering and virtual clouds can be used in design, prototyping, testing, simulation, and verification process. It focuses on the art of deploying the fourth industrial revolution technologies and improving productivity, increasing automation, and minimizing waste and incidents. We have selected three interesting topics that will be presented by three of the gurus of smart engineering. Please allow me to introduce our esteemed speakers for the session. Mr. Mark Edelman, Director of Projects from Jacobs 8, who will share with us how integrated digital assets and intelligent performance metrics could help in achieving predictable outcomes. Mr. David Cole, Technology Solution Director from KPR, who will be enlightening us on how smart solution could help in achieving a sustainable future. And last but not least, Mr. Stefano Bulimeni, the VP of Operation Rome Business Unit from Technip Energies, who will share with us how smart engineering could inject value in all phases of capital investment. Without further ado, please allow me to introduce Mr. Mark Edelman from Jacobs 8 to start his topic.
Good. Thank you very much for having me as part of this event. I think smart engineering is a very big topic, and I hope to do it justice in the short time that I have available. But let's get to it. My name is Mark Edelman. I'm the Director of Projects for Jacobs 8. I'm very happy to be here. First, I think we need to ask ourselves, well, why smart engineering? And there's a lot of reasons why smart engineering, but I tried to summarize this the best I could into three key points that you will continue to see over the conversation if you haven't already. One would be an integrated digital asset, right? And the key word here is integrated. Also, intelligent performance metrics. We need to understand in this ever complex world how we are performing and how we are progressing so that we make sure that we stay aligned in our goals and objectives. And finally, ultimately, what we want to achieve through this is predictable outcomes and improved quality. You may have heard this in many of the presentations before. We need to become more predictable in the way that we execute projects and also in our outcomes. A brief view of just the way that specifically engineering has progressed over the last years. Some of us are old enough to remember the days when we used to make everything on paper and then slowly moved into CAD systems, which was basically a digital way of doing manual drawings. And then over the last few years, we evolved into 3D modeling, which revolutionized the way that we visualized our assets. We no longer had to build physical models with little straws and pipe, but we could actually visualize it and turn it and zoom in a 3D model environment. Now, all of that has taken us down the road to a really a data-centric, the need for a data-centric approach to engineering. And what do I mean by that? It's the fact that you are no longer going to be dealing with and doing your design in the final deliverable itself, but you do your design in a platform that is virtual, digital, and includes all of the data and information that you need ultimately to be reflected in your final outputs. But you're not directly working on the final outputs. And then how do we make the change, and what does it mean to go from data-centric into smart engineering? And I'm sure there'll be all kinds of definitions, but the way I define it is that data-centric is a static, if you will, a static view of it. You have your information in a static form and you have it all in one place, a single source of truth. But the move to smart engineering is a dynamic, live approach to this data-centric database, single source of truth, is the ability to make modifications, to run scenarios in a live environment without having to wait for a design review and then have to wait weeks for the design, comments to be incorporated and then go back and have to make changes back and forth. This smart engineering would allow us to make iterations in zero time live and see how the design could be optimized without having to delay schedule and without having to spend additional resources. I'll continue here to see what are we talking about when we talk about this data-centric approach and the smart engineering, because it will change, and it already is changing the way that we approach engineering. And I would put it into different buckets. One would be the data gathering exercises. We see a suite of technologies available to us at the moment to gather data from the field, especially when we're dealing with brownfield facilities. Some of these facilities are very old. The as-built database in these facilities tends to be incomplete at best and inaccurate at worst. So we need to rely on what we can see, what we can measure, and what is actually there. We have laser scanning, we have underground radar mapping, we have a whole suite of technologies available to us. And the idea is to gather all that data and put it into a central repository where it is available for all the designers to access. Then we look at data processing. So how do we take all of this good data and work with it to create a design? So this is where we need to have an integrated platform that is able to draw from all that existing data and is able to give the engineering company the ability to modify and run different scenarios and different layouts of and configurations of the design. Also, this will necessitate and this will aid as well in standardizing outputs. If we can spend more time working on the integrity and the value of the design, and we have standardized the output deliverables, which, by the way, have been already standardized with the inputs of operations, of construction, of all the different stakeholders, so that we're all speaking in one language. And that can very easily be incorporated into this integrated platform. And also goes without saying that this platform would allow us the ability to give intelligent performance metrics, just so exactly how, what is our progress per area, per system, and see whether we do diagnosis to see whether some teams are performing at their maximum or whether they need intervention. And finally, at the point of handover and turnover of data, we would have a digital twin that basically makes sure that the data that is captured at the very beginning of the job is continuously fed all the way through the final turnover to operations. And then we would do a recycle loop where all that data is managed and is stored and kept up to date, so that the next person coming in, a next team coming in and doing a project is drawing from the absolute latest data available.
Thank you, Mark. Thank you for enlightening us with a very interesting topic. Mark, what do you think of the 7-dimensional BIM and other recommendation practices for the handover, like the capital facility information handover specification, or the CIFOS?
Yes, absolutely. And this is a little bit of what I was talking about when we involve more stakeholders across the supply chain, not only engineering, but everybody will have to ultimately speak the same language in terms of data. And a language which would be easily recognized by by the same platform. Everybody would be able to maybe use their own software, but all speaking the same language. You'd be allowed to integrate all of that into one seamless design.
Excellent, excellent. And how do you think the digital asset within the project management can help in improving safety, asset performance, and reducing incidents?
Yeah, and that's a great question, because look, with this smart engineering and the tools, the attention and the focus of engineering can actually be on making a better design, a safer design, and optimal configuration. Right now, as you know, a lot of the time goes into manual updates of drawings, maybe manual intervention, a lot of checking, but smart engineering, a lot of that happens automatically. So there's a lot more time available to run scenarios and really optimize design.
Excellent. So what's your recommendation for the smooth handover of a project deliverable from the intelligent asset commissioning, operate and maintain?
The key is to start early, and it comes down to starting your platform early on through the engineering phase. As you go through the project, it becomes increasingly difficult to integrate this data-based approach. So start very early.
Thank you, Mark. Thank you for sharing your insightful presentation. We really enjoyed your topic. And now let's move to the second presenter, Mr. Dave DeCole, who will share with us, the smart solution for a sustainable future. David.
Thank you. Can you see my screen okay?
Yes, we do. Yes.
So I'm David Cole, Director of Project Solutions at KBR, and my presentation today is entitled Smart Solutions for a Sustainable Future. So I just wanted to start with some reflections on the World Energy Outlook 2021, and really the interests of that were on COP26 this year in the UK. So firstly, we have one emphasis that comes across is low carbon solutions are overdue. Technology and innovation is critical in reducing carbon emissions, and clean energy is needed at scale. So firstly, low carbon solutions. So a lot of people at the moment, you see the graph on the right, are looking at operational carbon and reduction of operational carbon. But as we move forward in time, the importance of embodied carbon will become ever more important in our designs. And therefore, when we look at equipment and materials that we purchase and the designs that we do, we need to look at things like dashboards, as I showed below, where we can show where that embodied in carbon is. So technology and innovation is critical. So what we need to be aware of is that our clients will have requirements. And so we need to get away from the standards in writing specifications to requirements management and to suppliers sending data into our cloud databases. And we use that data definition, our requirements or requirements management for our clients, and ourselves providing rule sets in our cloud that then drive the 3D models and create those digital twins, which is what I'm trying to show in the diagram. So the other thing of importance is clean energy is needed at scale. And we can do that by starting to use some of those things I mentioned in the previous slide. So again, we got requirements. What we've done at KBR, we're able to identify locations in Google Earth, and then we can optimize the design automatically in the layout of what we see on Google Earth. So all that data, so you remember in the previous slide, we've got rules from engineering, we've got suppliers data, which creates that digital twin automatically, and we've got the client requirements. So we can then go through an optimization phase and then into design and issue of construction drawings. And that process can be much, much quicker. So it will change what we currently see as our design processes. And that's all data that's held in the cloud and available for a global execution. So what we're actually saying is, in conclusion, is Smart Solutions for a Sustainable Future was the title. So low carbon solutions are required at scale. So don't be part of the problem. You need to be cognizant of the fact that you need to understand. You need to calculate the carbon from the start of the project. So you need to look at both the embodied carbon in your design and in operation. So to address those emissions early, so in the previous presentation, we talked about digital twin. So we need to build that digital twin from the start of the design process. And we need to start the digital twin of those emissions right from the start, and that will come from the data that we have from suppliers. So automated engineering puts that carbon footprint in the front of the design process. So as we have requirements that we get from our clients, our international requirements that we get from standards, and our rule sets that we get from our SMEs within our companies, we're able to provide data that automates that design. So technology and innovation is critical. So speed of adoption is critical. So we need to be looking at what technologies are available and how to use those in providing design at scale. And we need to embrace the idea of innovation. We talk about agile as well. We need to embrace those new ways of thinking and to achieve the idea of net zero. And our automated engineering solution provides innovative engineering solutions. We need solutions like that to produce those digital twins early to look at carbon emissions. And clean energy is needed at scale. So the automated engineering idea gives you that scale up, but also gives you that idea that you can also look at your emissions. And we also have technology age is the ability to meet the demands of clean energy. So I think you need to be sure that you're using the technology that's used in the right way, so we can meet the challenges of reducing emissions. And AES and things like that with the digital twin as well will provide those technologies that enable us to reduce emissions, and that's all possible through the technologies and things like the cloud that we were talking about today. And that's my presentation.
Thank you, David. Thank you for a very insightful presentation. So, David, can you elaborate more? What is the role that digital transformation is playing in achieving the net zero pledge and targets? How can people are to use these technologies to help in achieving these pledges and targets?
So, we talk about the digital twin a lot in presentations. You see that it's one of the main tool sets you have, and being able to model the carbon emissions both from an operational but also how we do our designs from an embedded position will give us that ability. So when we talk about starting with the end in mind is another classic line, and I think it's using the digital technologies we have, using the supplier data that comes into the cloud, and using those databases to be able to design in a carbon cognizant approach. That's how we're going to get to net zero.
Thank you, David. And in your opinion, what is the most important phase of the project to minimize the impact on emission and to achieve sustainability?
Obviously, the start. It's no good reporting emissions as we go, so we know what they are, and then think, well, how do I reduce them? We need to look at the design, and then look and optimize the design both in terms of cost, in terms of reducing schedule or de-scoping, and that will give you reduced emissions. And looking at alternative materials, we can change material types before we go into construction, and we can look at how that can reduce the embodied emissions. But we can also, because we've got that digital twin, we can also model our plant and see how the operational emissions can be reduced by changing the design in the early stages. The further we go in design, the less chance we have of changing that outcome.
Excellent. So one last question is, do you think that the use of the cyber physical system or manufacturing operation management can help in reducing and governing the GHG emission from the beginning of the project?
Yeah. So we need to protect our data, but we also need to look at the operations from manufacturing in looking at how carbon is emitted, and therefore optimizing that process.
Thank you, David. Thank you for a very excellent and exciting presentation. And now we will go with the third presentation with Stefano Polemini, with a title of Smart Engineering, Injecting Values in All Phases of Capital Investment. Hi, Stefano. Hi.
I'm very sorry, but we got by chance an internet failure just right now. So I'm connected through my phone, from my mobile phone. So sorry for that. Sorry for the delay. Sorry to the audience.
It's okay. It's okay. It's part of the digital transformation. So
let's okay, exactly. So just 1 minute to introduce myself. I'm Stefano Polimeni. I'm in charge of the operations of Technip Energies in Rome business unit that is taking care of all Middle East. And I'm also a board member of Tidarek, that is our company operating in Saudi Arabia, a Just Plus contractor for Saudi Aramco. So let's talk about smart engineering, and that we put in the title of our presentation this sentence: injecting value in all phases of capital investment. Why we are saying that? Because actually we see the smart engineering as the let's say the tool, the real instrumental tool to inject value in all phases of capital investment, from concession to master planning, commissioning, operation, and decommissioning. In Technip Energies, we identified 3 main pillars that jointly shall contribute to a step change in our project sustainable performances. The 3 pillars are the ones that are in the slide. So digitalization, standardization of all parts of project execution in single platform, using lean and data-centric methods. AI and knowledge management tool to automate design activities, increasing productivity and reducing time to marketing. The third one is immersive visualization collaboration tool to enhance stakeholders' involvement in the capital project's value stream creation. Let's see one by one how we are progressing in Technip Energy in these streams. So, okay, that's similar to slide that was shown in the presentation before by our colleagues. Here we put also something more, that is how we executed project depending on the availability of let's say tools and technology, but also how we evolved in the very important aspect of the design integrity, quality planning along years up to where we are now. And we are now, okay, in a phase in which we are extensively using the 3D modeling. We are consolidated procedures for to check the design integrity and the quality of our design and the planning of our activities. But we believed some years ago that we need to make a step change. Now we were approaching the projects. And what we figure out and what we designed at the end, we consolidated a decision to go to a PLM-based infrastructure and to develop a completely new paradigm for our project execution. You will see the same aspects of design integrity, quality planning are addressed, but they are addressed in a totally different way. So this is because we wanted to avoid the fact that we are still seeing in our engineering activities. So our practice is still prone to silos design, data inconsistencies, and a complicated, ineffective, and over documentation. We now are going to an approach that was already proven successful in the manufacturing industry. And we are conceiving our new approach on a data-centric base, and we have totally redesigned project work processes, execution work processes. Yeah, we have 3 main parts of what we are redesigning and what we are doing in our organization these days. We started this ambitious plan let's say, 1.5 years ago. And we are using a central platform for project execution. In our case, we selected the DRS Innovator platform, low-code environment, so no big development. We don't want to become software engineers. We don't want to be software developers, independent from engineering authoring tools. Second part of this important project is the complete redesign of all our work processes under a data-centric approach, involving the full supply chain. So our subcontractor, our suppliers, and all stakeholders, so clients, operation teams, external parties. Third part of our project is the standardization systems and components. In beginning 2022, we are starting seeing the first effect of that. We are going to deploy a significant amount of functionalities or new functionalities and new redesigned work processes in our practice. Second, let's discuss a little bit how we are using robotic automation and how we are using knowledge management. This is a brief description of a tool that we developed. The name is Stilo, Stilo Optimizer, for the optimization of the, it's the slide before, sorry. For the optimization of this structure, it's this, if you can come back one slide, please, another one. Okay, this is a tool that we use for automation or design of this structure. Integrates all the authoring tools that we use for design, geometric modeling, and calculation. And we are just removing all routinary tasks from the designer, leaving them the time to perform more added value activities. This is bringing to a saving from the preliminary design to the fabrication of more than half of the engineering man hours and time needed with a traditional approach. This is already working. This is really a fantastic development that we are implementing for with the robotic automation.
Finally, it's indeed a very fantastic idea. Thank you, Stefano. So how could we achieve, in your opinion, zero waste and improve circular economy using these technologies?
Okay, this technology, first of all, they are linked by design. So actually, we are implementing a system engineering approach. We are trying to avoid all wastes of all kinds in our activity. Wastes that is time, but it's also an necessary cost, making all the silos inside our organization and with our supply chain. It's really an opportunity to go into a lean approach that eliminates waste. Circular economy, I mean, we are also technology provider. You know that energy transition projects are the best candidate to implement these new technologies. They use a slightly different business model from traditional engineering. They are much more related to, let's say, supply of technological packages. And we believe that by this, the use of these systems and by smart engineering, we are really promoting a circular economy in the new technologies.
Thank you, Stefano, and thank you, dear Mark and David, for an excellent presentations and insightful thoughts. And thanks to the Project Execution Technology Conference for giving us the chance of sharing this insightful information. I hope that you enjoy. Thank you very much.